Thank you very much. Thank you all for being here in one more event of this fitness project. Following the presentation of Sandra, I will present now some examples of studies that have been done in using one of the tools that was mentioned, life cycle assessments in different systems for food packaging. So I will do a short introduction, and then I will present a few examples where LCA has been used with different objectives, like comparing different packaging systems to assess the impact of recycling in glass bottles, to make comparison between single-use and refillable, the impact of lightweighting, and if we have time, impact on international distribution. And then at the end, a case study that we have made in our faculty. So a little bit of introduction. You may find more detail, more technical information in a lecture that is online in our fitness platform about the tools itself and the different steps. Here I will present just briefly and an overview of the tool, and then I will jump directly into the examples. So very briefly, LCA studies evaluate the environmental performance through the packaging life cycle by quantifying extraction and consumption of resources and releases to air, to water, to soil, and this is through all the energies. So the LCA studies, they assess the potential contribution to different environmental impact categories. And I name here a few, like climate change, human and ecotoxicity, resource deterioration, for example. There are a number of different environmental impacts which may later be combined or not. In this picture, we see that it's a very, very well-known picture where we have the framework of a life cycle assessment study, where first we define the goal and the scope, then we go into a phase of inventory analysis where we collect the data. Then using different sources and tools that may be available, we assess the impacts, and then we have the interpretation where we extract the conclusions and we present the results. And like Sandra said, the goal and the scope should be very, very well defined so that the interpretation can then be very transparent and all assumptions can be clearly stated, so that the validity of the study can be assessed. The process or the cycle, the chain description is essential, is the first point, and we start from raw materials acquisition, materials production, the packaging system production and assembly. Then we have the packaging use, and finally the packaging disposal. So here we present the full process, but depending on the study, we may define the system boundary, the system that is going to be focused on the study, and our study may not include the full process. So it depends on the objectives. Again, the important point is that wherever and how the boundaries of the system are defined, it should be very, very clear, stated what is in and what is out. Depending on the or in the definition of these system boundaries, we need to take into consideration functional aspects, quality and safety aspects, and the food processing. Again, this may be more complex or less complex depending on the system that we are approaching. LCA has been applied in the packaging since the 60s. Back then, it was very much, the studies were very much focused on energy use and resources use. Later, waste management started to be focused, and now more and more we have comparison of different packaging systems. We have comparison, for example, of the use of biomaterials based. Is the studies focusing on this aspect are quite trendy. And more incorporation of shelf life and decay of the product factors are starting to be incorporated in the studies, LCA studies. I will focus the examples that I will present today in wine. So all examples are from wine. We know, and in this slide we have here the different packaging systems that typically we can see in wine, like the glass bottles, plastic bottles, mostly PET bottles. And then we have what we call bag-in-box systems, BIB, from bag-in-box, and liquid cartons, so laminated materials combining paper and board, aluminum, and plastics. These are the most used for consumer packaging. We may have some systems larger for transportation and for non-consumer packages, but most of the studies address these examples. The first example is the comparison between different packages. We understand that for this type of product, for wine, the packaging system has a major impact on the product properties and on their evolution over time. So comparison of different systems is only valid when focusing on products of equivalent value. So we cannot compare a very high quality wine, which is unlikely to be packed in a less traditional system with such kind of products. The first example is taken from this publication, where those 5 are alternative packaging systems in Italy were were compared, and so they considered the single-use glass bottle, the laminated multi-material boxes, the bib, a refillable glass bottle, and a multi-layer PET bottle. As I said before, in order to be fair in the comparison, we need to find the functional unit. And because some of the bibs or most of the bibs are with a capacity higher than 1 liter, in this case, the functional unit was set up as 3 liters of wine in order to be able to compare the systems with different capacities. Palletization efficiency was also considered, and it was maximized. It was considered the optimum. The pallet load patterns was optimized using simulation tools, and therefore the optimum for each type of packaging was considered. Another aspect that we need to consider is the end of life and the disposal scenario. So what happens at the end after use of each packaging system? And we may have incineration, landfilling. Some of the systems are recyclable. And this depends, of course, from country to country. Rates are different, so in this case, the values applied to Italy were used. And in this case, glass bottles were considered to be around 70% recycled. The bibs, the bag, so we have two components, were considered to be 40% landfill and 32% incinerated. Only 27% could be recycled. PET bottles were considered to be 43% recycled. Corrugated board, most of it could be recycled. And the refillable glass bottles, the inputs and the emissions from the bottle washing process and refilling was also considered. And here are the results. And in this case, the impact categories were grouped into 3 main categories of damage. That was the impact on the resources, the impact on human health, and the impact in ecosystems. And in this picture here, we can see, in fact, the comparison of 2 studies, one in Italy that I mentioned, and another one in Canada. And we may see that after normalization to the glass bottle single use, what we can see is in fact, the bag-in-box was the best performing option, following by the laminated boxes. And of course, these were considered lower because of the higher palletizing efficiency, which because these systems require less secondary and tertiary packaging, and because they are geometrically squared, the pallet use is optimized. Then PET bottles was around 50% of the glass bottle single used, and the reusable glass bottle was considered, if it is reused 15 times, it's also very, very interesting in terms of the lowering the impact in comparison to the single use. The impact of recycling of the glass bottles, this is well known. We know that the virgin glass is responsible for about 30% of the carbon footprint of when we look into the overall chain of wine. So it's very, very relevant. So the recycling has a high impact on the disposal scenarios, has a very, very high impact on the final results. And we know that glass melting requires huge amount of energy, and we also know that remelting recovered glass requires less energy compared to the energy needs to melt raw materials, and this is why recycling of bottles is very, very let's say positive in reducing the overall carbon footprint. And we have here a few results that you can check up later. Another study was the comparison between single-use and refillable. So, of course, here we need to considering the recycling scenario, the transport to waste center, to shredding, all the washing, then transport back to the glass production, and then the glass melting and handling, and the bottle forming, as I explained, with energy savings. While in the reuse, we have the transport to the washing center, all the washing impacts and drying, and then refilling. And these are illustrative results. We know that reuse is negative impact, very negative in the sense that it really improves by lowering the carbon footprint. We have only a positive impact in fossil depletion, because we still need to incorporate some version. Typically, it's not possible to do because it's not available completely 100%. So in this picture, we can see clearly how benefit can be reuse the glass bottle for wine in all indicators that were considered. I will jump this a little bit to go with the impact of lightweighting. Lightweighting is not so much known by typical consumer, because lightweighting means decreasing the mass of glass bottle, still holding the same volume of wine, and maintaining the characteristics, the functional characteristics of the bottle as much as possible in terms of mechanical resistance, for example. And because the consumer is not so much sensitive to the weight of the glass bottle, most of the studies indicate that consumers are not so much sensitive to this strategy, although it is considered by industry one of the most promising, and I cannot say promising because in fact the history has shown that in all materials, from plastics to metal to packaging, in plastic, all materials have been and all industries have been trying to reduce as much as possible the weight of the different packages, whatever the material is made of. And LCA studies for assessing the impact in single-use glass bottles for wine has shown that, for example, a 10% decrease of the bottle weight, if we consider the regular 750 SL wine glass bottle, would result in 6% decrease in the indicator for global warming potential. So this is quite relevant, and this is something that we need to consider. Going a little bit on the impacts on international distribution. In wine, this is a very, very important aspect. I will not go in all details that I have here. You can read the slides later on, but as we all know, wine are produced in specific areas of the globe, and from those areas, wine is distributed all over. And depending if there is distribution by using sea or roads, the transportation scenarios change a lot, and depending on the country that is receiving the wine, a major impact occurs. In this case, as you may know, there is two opposite trends, because when we analyze the results from LCA, we find that if we have bulk distribution and the wine is then bottled in not in the origin country, but in the receiving country, then the overall impact is very, very much reduced. But of course, this has implications in terms of safety, quality, but mostly on fraud. It's because when we have bulk distribution, there are always the afraid that the origin is not guaranteed. And of course, the region origin is very important for wines. So wine producers countries are, let's say, hindering this possibility of having wine transportation in bulk and filling at the let's say buying country. If the law, if agreement is achieved, a major impact can be saved, because, as I explained, the impacts are much lower than if the wine is packed in the origin, as is made in most of the cases today. So these are two examples addressing what I just explained. I want to, for the last 5 minutes that I have, to go over an example where we also for a glass bottle of wine, but the study aimed at assessing different labeling options. In this case, in these pictures, we see examples of the labeling. These were not the samples considered. By obvious reasons, I cannot present here, but just to illustrate, we may have a glass bottle with a sleeve, a plastic sleeve. We may have the glass bottle with painting and serigraphy, and we can have a bottle with serigraphy made with ceramic ink. And so in this case, this company wanted to assess these different processes. They were the three in option, and this was very, very relevant for the company because due to the logistics organization, because the company has different plants located in different where different processes are located in different plants. So they wanted to do an assessment on taking everything together. What could be the labeling option with less impact. For the end of life, the bottle was considered to be recycled. The bottle was always the same, so we didn't focus on the bottle production, but only on the painting, on the labeling process. In this case, the sleeve was considered partially incinerated with energy recovered. So the scope and the functional unity, the geographical location was between Portugal and Spain because the company has different plans. The functional unity was a single bottle, and as I explained, the system didn't account to the bottle itself, only the labeling processes. So we had transportation, we had decoration, labeling, and then we had transportation again. And so I will not go into the full details, but just to explain briefly the process. So we were finding out where the bottles were transported from where to where, depending on the process, the type of pallets, how much material in each pallet, what type of trucks, all the materials that were used between layers, plastic cover, and so on to secure the pallet. And then we were inventorying all the inputs and the outputs. In one word, to describing the process flow. So in the case for this transportation, as you see, different processes were coming from different cities and going to different cities, so everything was detailed. Then we went to the decoration process, and for example, for the sleeve, there was a depalletization, and then there was a tunnel to warm the bottle. Then we had the machine that applied the sleeve. Then we had a tunnel that shrink the sleeve, and so on. And so the inputs in energy, in natural gas, and the residues, the wastes in each process was all inventoried. This is the same for the bottle with serigraphy. The process is different, of course. And for the bottle with painting and serigraphy, the process was a little more complex, but everything was done and described. What was important in this study and allows me to highlight this as an example is the source of data. We cannot do LCAs without data. Of course, we have softwares and programs that bring or have inbuilt some database, and of course this is something that we can use, but the most impactful, let's say, studies will use proper specific data from the company, from the process that is being addressed. So this is something that we need to consider when designing our study. And in this case, we had a mix. We have some data from the company. We had some emissions, for example, from national inventory of atmosphere emissions that was available. For transport, we use data from this database, and this was the software that we used at the time. Showing very quickly the results. Before that, these were the impact categories that we considered. Depending on the system that we are studying, some are relevant, some we may leave out, and in this case we select these four. And I want just to show you that in these impact categories, for the different labeling processes, we when we compare after expressing the impacts in common units, we see immediately that the sleeve tend to be less impact than the serigraphy and the painting with serigraphy. And these are the results for global warming and fossil resources depletion. And well, here you can see clearly that the painting and serigraphy has much higher impact due to electricity and due to natural gas. And of course, we understand, because if we have seen the process in detail, which today we don't have time, we see that the furnaces need to cure this type of painting ink are very, very energy consuming. And the problem is that furthermore, this labeling process requires two times going through the furnace, which increases even higher the consumption. And to summarize, we can see here that we could rank the sleeve as the least environmental impact, also the lowest cost, while the painting and serigraphy was in the opposite level of the scale. Of course, this does not include the impact in the consumer, because in one case, what the consumer sees is a plastic sleeve, which may somehow limit or give some condition to how the consumer perceives that bottle or that wine, but numbers are numbers, and this is what the results were. One additional and last point is that when we use a sleeve in a glass bottle, because the sleeve is a label all around, surrounding all the bottle, we may maintaining the safety and security issues, we may even more lightweighting the bottle. So in fact, that was not considered in the study, but it could be in a follow-up, that using this sleeve, we can use a bottle that was lighter than the bottles that were for the same product, but painted and or labeled as with serigraphy. This was, I hope, a good illustration on how LCA can be used in to give us different answers to address different aspects of the impact of the environment. And with this, I thank you your attention, and I will be available for any question now or later in the session after the next speaker. Thank you very much.